You have likely never heard of this tiny creature. It is a life form so uniquely tied to its home that it exists nowhere else on our planet. Its entire world is contained within the confines of a single secluded valley in the vastness of the United States. This is not the story of a majestic lion or a soaring eagle. It is the story of something much smaller, something far more fragile, something on the very precipice of vanishing forever. The creature is the Eureka Valley dunegrass, a humble, unassuming plant that holds an entire ecosystem in its delicate roots. Its struggle for survival tells a much larger story about secret worlds we stand to lose. A valley can be an island of land, surrounded by mountains or arid plains. Its unique geology, the story of how we came to know many of these hidden species, is often one of serendipity, patient observation, being in the right place at the right time. The Eureka Valley dunegrass, Swalenia alexandrae, was not discovered by a grand expedition seeking new life. It was first scientifically described in the mid-20th century by botanists exploring remote desert corners. They were likely drawn to the valley by its immense dunes and stark geography. Walking across the shifting sands, they would have noticed these lonely tufts of grass, an unexpected splash of green in a world of ochre and gold. It looked like little more than a hardy weed, tough and wiry. To a trained eye, however, its uniqueness was apparent. Its structure, its root system, and its method of survival were unlike those of other grasses in the region. The threat it faces is quiet and creeping. Subtle shifts, water tables slowly falling, invasive species arriving like silent invaders, and a climate becoming warmer and drier. For a species honed for specific conditions, small change can be catastrophic. When the Eureka Valley dunegrass disappears, we lose more than one species. We lose a chapter in the story of life, a genetic library of resilience, and a key that holds a tiny, unique ecosystem together. For the Eureka Valley dunegrass, the threats came not from bulldozers or chainsaws, but from changes that were nearly invisible. For decades, agriculture in the surrounding regions began to draw more and more heavily on the underground aquifers. These vast subterranean reservoirs of water are the lifeblood of the desert. They feed the hidden springs and seeps that allow life to flourish in the most arid of landscapes. As the water table lowered, the deep roots of the dunegrass had to reach further and further. The very foundation of their existence was being slowly drained away. Clumps that were once vigorous began to shrink. Fewer seeds were produced. The plant's ability to anchor sand and stabilize its patch of dune was diminished. A slow retreat masked by the desert's silence. To truly understand what is at stake, one must imagine walking through this habitat. Let us take a short field tour. We arrive in the cool of the early morning as the sun begins to crest the jagged peaks of the Last Chance Range. The air is still and carries a surprising chill. The immense dunes rise before us like waves on a frozen ocean, their surfaces sculpted by the wind into impossibly sharp ridges. The silence is profound, broken only by the soft crunch of our footsteps in the sand, and the whisper of a breeze that begins to stir as the valley warms. The scale of the place is immense, and it's easy to feel small and insignificant. As we begin to climb the lower slope of a dune, we look closely. The sand is not uniform. It is a mosaic of different grain sizes and colors. Here, we find the first tracks of the night's activity. The delicate stitching of a darkling beetle, the shaped trail of a sidewinder rattlesnake, the tiny footprints of a kangaroo rat. These creatures are masters of this environment, spending the brutal heat of the day in cool burrows deep beneath the sand. They are part of the dunegrass's world. The kangaroo rat may gather and store its seeds. The burrows of nocturnal animals help to aerate the sand around the plant's roots. The Eureka Valley dunegrass is not alone in its singularity. Its story is representative of countless other endemic species, each a unique thread in the rich tapestry of life on Earth. These organisms are the living embodiment of place. Think of the devil's hole pupfish, a tiny iridescent blue fish that lives in a single water-filled cavern in the Nevada desert. Its entire species, its whole universe, is contained within a pool no larger than a living room. Its existence depends entirely on the constant temperature and chemical balance of that one geothermal spring. A slight change in the water level could spell its extinction. Consider the case of island species. On the Hawaiian Islands, evolution ran wild in isolation, producing thousands of species found nowhere else. Hawaiian honey creepers evolved spectacular beak shapes to feed on different flowers, insects, seeds. Sadly, many have already vanished, victims of habitat loss and diseases carried by introduced mosquitoes. Endemism is not limited to animals. Catalina mahogany on Santa Catalina Island, narrow-leaf yucca and agave restricted to single mountain ranges, each tells a story of geology, climate, and time. Their survival depends on preserving tiny homelands from development, mining, and the accelerating impacts of climate change. Often small and overlooked, they lack the charisma of a panda or a tiger, yet their importance is immense. Ultimately, the primary threat to nearly all endemic species is the ever-expanding footprint of humanity. For the Eureka Valley dundergrass and its neighbors, the abstract concept of human impact becomes devastatingly concrete. The pumping of groundwater for distant farms and for cities is a direct consequence of our civilization's thirst. We turn on a tap in a city hundreds of miles away, and the roots of a desert plant find a little less life-giving water. It is a stark reminder that ecosystems are interconnected in ways we are only beginning to understand. Pollution knows no boundaries. Airborne pollutants from industry and agriculture can travel for hundreds of miles, settling in pristine places like Death Valley. Pollutants alter soil chemistry. Plastics and litter mar the landscape and threaten wildlife. A desert tortoise might mistake a plastic bag for food. Climate change brings hotter temperatures, longer droughts, shifting rainfall, and harsher sun, disrupting the seasonal rhythms to which endemics are tuned. Even well-meaning visitation can damage cryptobiotic soils or spark wildfire. We must balance access with care. Connecting people to these places builds conservation, but stewardship, gentle, informed, and restrained, is essential. And so, we are left with a question that echoes in the vast silence of the valley. What does it matter if one small tough grass disappears forever? In a world filled with immense human challenges, why should we concern ourselves with the fate of a plant most people will never see? The answer begins with the simple fact of its existence. This dundergrass represents a unique evolutionary journey, a story of life written over millennia in the language of DNA. To allow it to vanish is to tear a page from the book of life, a page that can never be rewritten. The dune grass is an ecosystem engineer. Its roots bind sand, stabilize dunes, and create habitat. It is the anchor of its community. Its disappearance could trigger a cascade of local extinctions, unraveling a tiny, intricate web of life we do not yet fully understand.